Hi, Assalamualaikum warahmatullahi wabarakatuh. Well, here is a summary of some formulas that I'm pretty sure you have seen before. So these are the formulas related to how the group of objects can be selected and ordered, and these formulas will be used according to the situations given. And in this video, I'm just going to talk about a specific problem of arranging and distinct objects. So basically, how do you arrange objects that are distinctively different from each other? And you will see that later on, you can use this formula in order to answer questions that is related to this arrangement of n distinct objects. Now let's look at the problem given here. First of all, I'm just going to define the idea of permutation. So permutation is defined as how you can arrange n different elements of a set, and you will see that in order to think about this arrangement, you can also think about it using theorem 1.1. So you can use the idea of basic counting rule in order to answer any question about permutation of n different objects. Okay, so I'm just going to illustrate that first. Now in this question here, we have letters A, B, C, and D, and the question is asking you how many permutations are there. So how can you arrange all these four letters? How many ways to arrange all this? Now if you think about using the idea of basic counting rule, which is theorem 1.1, you can start by having a big problem. The big problem is arrangement of four letters. So this is your main problem. Okay, so you can think about it as having four spaces. Okay, so you're just going to decide what letters that you should put in those four empty spaces. Now obviously your first step will be to choose what letter to be put in this first place. So your first step is to choose the first letter. Okay, so since you have four letters altogether, then the number of choices that you have for the first step here is going to be 4. So n1 here is going to be equal to 4 because you can choose either A, B, C, or D. Okay, so that's the first step. Now you can think about it as moving on to the next step, which is on the second step. So on the second step here, the process is actually to choose the second letter. Okay, so this space is already filled up with one letter, and therefore you are left only with 3 letters. So here the number of possible choices that you have is going to be 3. Why? Because this space is already filled up when you did the first step. Okay, now next we move on to the third step. The third step is basically you're going to choose the third letter. Okay, and obviously since this space is already filled up, by whatever letter, we don't really concern ourselves with whatever letter there is on these spaces here. So now the number of choices that we have is going to be is equal to 2 because you only have 2 letters left. Okay, does it make sense to you? I hope it does. Okay, and the last step, so this is the fourth step. The fourth step is to choose the fourth letter, and basically you don't have any choice because you only have one left. So here n4 is equal to 1. And according to the idea of basic counting rule, the arrangement of 4 letters, okay, how many permutations are there, or how many possible ways that you can arrange 4 letters, are just going to be obtained by multiplying these results here. So we're going to multiply those number of ways in 4 different stages. Okay, so the number of permutations are just going to be 4 times 3 times 2 times 1, and this is equal to 24 different ways, or number of permutations is equal to 24. Okay, so that is how you can solve this problem by using the idea of basic counting rule, which I have already illustrated in the previous video. Now, I also hope that you can see this number here is pretty special, kind of unique. Okay, it's a multiplication of 4, 3, 2, and 1. And basically, this is actually similar to the idea of having 4 factorial. Okay, so this is 4 times 3 times 2 times 1. This is actually 4 factorial. Okay, we have 4 letters and you want to arrange 4 letters, and the result here is equal to 4 factorial. So 4 factorial is equal to 24. And therefore, you can see that sometimes when you want to solve this kind of problem, you can also use this formula here, which is n factorial. So if you have n objects, you can arrange them. The number of ways to arrange them is going to be equal to n factorial. So I hope you can see that the idea of basic counting rule, which I have illustrated in the previous video, is going to lead to the solution of having n factorial. Okay, so there are 2 ways of doing or solving this problem. Yeah. Okay, let's look at the next example. Suppose that the performers in a musical gig will be introduced one by one on stage, and the performers of that night are Selena Gomez, Justin Bieber, One Direction, Taylor Swift, and Meghan Trainor. So we have like 5 different performers, and they are all different from each other. So there are 5 distinct objects, if you want to assume that as such, or 5 different people, 5 different artists. So in how many ways can these performers be introduced to the audience? So it is the same thing as having 4 letters and how you can arrange them. Okay, so it is the same problem really. And like I said earlier, we can think about it by directing our thought into basic counting rule. Okay, so we are going to try and visualize this as one big problem. So the big problem is introducing performers one by one. Okay, one by one. So how many ways can you introduce the performers one by one? So obviously we can have like the first step. First step is, of course, you are going to choose which performer. So you're going to choose the first performer. So first step is choose the first performer. So, and in this case, because you have 5 performers, so in the first stage here, you will have 5 different options. So n1 is going to be equal to 5. Okay, because this is the start of your tackling this problem, and the first stage here is going to have 5 different performers. You have that option. Yeah. Now, moving on, okay, to the second stage. So second stage or second step is to choose the second performer. So bear in mind that this place here is already filled by the first performer. Okay, so here we have n2 equals to 4. n2 equals to 4 because this one is already filled up by one performer. Now you only have 4 options that you can choose from, okay, to be the second performer. Next is the third step. Third step is to choose the third performer, and following the same idea, we know that if this space is already filled up, this space is already filled up, so 2 performers have already decided, therefore the number of ways you have here is going to be equal to 3. Okay, next is the fourth step. So here is fourth step, where you're going to choose the fourth performer, and bear in mind that this space is filled up, this space is filled up, this space is already filled up, so 3 spaces have already been filled up, so the number of ways that you can have now is reduced to 2 options only. Okay, and finally the fifth step is to choose the last performer or the fifth performer, and here you don't have many options anymore. You don't have options at all because this is already filled up, this is filled up, this is filled up, this is also filled up, so 4 performers have already been chosen, so you're only left with just one option. So sorry, this is n4, yes, n4, so this is n5, so n5 is equal to 1. Okay, therefore if we go back to the major problem, how many ways you can introduce performers one by one? So the number of ways is going to be, according to the basic counting rule, you're just going to multiply this value with 4, with 3, with 2, with 1. So here we will have 5 times 4 times 3 times 2 times 1, and this is equal to 20, 60, 120 ways of introducing these performers. And I hope that you can see the thought process that I've explained to you just now is about basic counting rule, but the result that we get here can be specifically narrowed down to the idea of 5 factorial as well. Okay, so we can write the answer here in terms of 5 factorial, and that's why sometimes you can see that if you want to skip the whole thought process here and answer the question in a straightforward manner, or in a manner that can reduce time, then you can just apply the formula which I have already demonstrated here, which is n factorial. Okay, that's all for now. Thank you very much for watching.